Alright, section 6.1 is an introduction into what's called polynomials or multiple numbers, multiple terms. We're going to be looking at polynomial functions in this chapter, finding the zeros with them, graphing them, etc., etc. And so to start off, we're going to identify what a polynomial is and then trying to be able to categorize them into different things. So the first thing, a polynomial. So a polynomial is a monomial or the sum of monomials. And what a monomial is it's one, mono, okay, which is usually means one term. And so this right here is just kind of the general form of writing it. So it's a constant times the variable x to some power. And the key thing we want to look here is what's called the degree of the polynomial. And the degree of the polynomial will be the largest exponent. So if you look at all the terms in this function, whatever is the largest exponent is the degree of the entire polynomial. It's not the first one, it's the largest one, okay? And that is also your leading term. Whatever has that largest exponent is also called your leading term. And the reason it's called that is because in standard form, what you do is you'll arrange them from descending order from their exponents. So an example of a polynomial would be 4x cubed plus 8x squared plus 7x minus 4. That would be an example of a standard form polynomial. And since it's degree 3, we would say, or since the largest exponent is 3, we would say it's a degree of 3. Okay. Now, these degrees have different names. And so here's kind of a table that shows different ones. So there's two ways of naming a polynomial. One is by the degree of it, and the other one is by the number of terms. Okay. So if you're looking at the degree, if it's a 0 degree, so there's no variable, okay, so the example here is 5. That is called a constant. Okay. If it's a first degree polynomial, it's a linear, just like we've had linear functions. A second degree is a quadratic. Third degree is a cubic. Fourth degree is a quartic. Fifth degree is a quintic. After that, 6 or higher. If it's 6 or more, all you just have to say is, like, 6 would be the 6th degree. Okay. If it's the 11, if there's 11 degrees, then you'll say the 11th degree polynomial. Okay. So anything higher than, if it's 6 or higher, you just say the number degree. Okay. 6th degree, 8th degree, 154th degree. Right, so that's naming it by the degree. So you've got constant, linear, quadratic, cubic, quartic, quintic. Okay, and then after that you just say what it is. Now the other way is naming it by the number of terms that is in it. So the very first one, you see there's only one term. Okay, there's nothing being added or subtracted. That's called a monomial. So if it's only one term, it's a monomial. Now if you look at this next one, the linear function, it's got two terms. Well, if you think of other things that have two, a bicycle has two wheels, so we would call this a binomial. Okay, two terms is a binomial. Now the quadratic, you've got three terms. Okay, three like a tricycle. Okay, 3 wheels, or a tri-10, 3 points. That would be a trinomial. Okay, so 3 terms would be a trinomial. Anything higher than 3 terms, so if there's 4, 5, 6, 7, 8, so on and so forth, those number of terms, you would just say a polynomial. Okay, so anything at 4 or higher, you would just say a polynomial. So if it's 1 term, it's a monomial. 2 terms is a binomial. 3 terms is a trinomial. Okay, so this is just kind of categorizing it. Okay. So if we want to name these following ones, we want to name it both by the number of terms and the degree. Well, what we'd want to do here is that we'd want to put it into, we'd want to simplify, and we want to put the leading coefficient first, or the leading term first. And the leading term in this one would be this 5x cubed. So we'll move it around, so we've got 5x cubed, then it would be minus 8x plus 8. This is the standard form. Okay, this right here is the standard form. Now, if we were to name it by the number of terms, since there's 3 terms, we would call this a trinomial. Okay, it's a trinomial. And since it's a cubic, or since the degree is 3, we would say it's a cubic. So this would be a cubic trinomial. Okay, 3 terms, the highest degree is 3. Now the next one, what we'd have to do here is that, again, we want to order it so it's largest to smallest, and then we also want to combine like terms. So to put this into standard form, we would combine the like terms, which would be the x squareds. 4 minus 7 is negative 3. So negative 3x squared plus 8x plus 6. Okay. And so now we would name it here. After we've simplified it, that's when you name it based on the terms and the degree. So in this case, we've got 3 terms, which means it's another trinomial. And the highest degree is 2, which means it is a quadratic. Okay. So this would be a quadratic trinomial. Now, even though this original one had 4 terms, we're able to simplify it down to 3. That's why it's a trinomial and not a polynomial. Okay, it has a more specific name. Okay, now with your TI calculators, okay, this is the step through for TI 83 or an 84, mostly. So what we're going to be looking at is regressions. And what a regression does is that if you have a bunch of numbers, a bunch of points, a data set, what you can do is you can create a function that follows along those points. Okay, and to do that, once you have your numbers, what you're going to do, once you have all your coordinates, you're going to go stat, go to edit, and then when that pops up, you're going to see a bunch of columns. And the first column should be named L1. Going from top to bottom, you're going to write in all the x values. And then under L2, you're going to write the corresponding y values. Okay, so in your column under L1, L2, you'd have 3, 4, 5, 7, 8, 10, so on and so forth. So you'd have the point 3, 4. You have a point 5, 7, point 8, 10. Okay. Now once you type those all in, you quit back out, go to the main screen, so second mode, push stat again, you go over to calc, so you'd slide over, and then you would choose either a linear regression, a quadratic regression, a cubic regression, or a quartic regression. Linear would just be x, cubic would be x squared, quartic or cubic would be, or quadratic would be x squared, cubic would be x cubed, and quartic would be x to the 4th. Okay. So if you were to take this, okay, these points, and when you type them in, okay, I would recommend having your calculator out, type all these in, and make sure you get these numbers matching up. If you were to do the linear equation, you would get this function. Y is equal to 0.572x plus 5.24. That's what you would get. The quadratic would get you this function. Cubic would get this one. And now the next question is which one fits the best? Okay. Now some of yours that might pop up, others might not. Underneath, when you do each of these, you might see r squared and r. If you don't, that's fine. That's okay. You just have to do a little bit. You have to put your diagnostic on. So you go to second catalog and go down to diagnostic on, turn it on, and then they'll pop up. But as you see, these squareds come up with numbers. Your goal is to try to get the closest to 1 as possible. So as you see, the cubic gets your r squared the closest to 1, which means that your cubic is the best fit out of all of them. Okay. Now to graph these regressions, once you have found your regression, you go to y equals, clear out the first one, the first y1. In y1, press vars, go down to statistics, I believe it's number 5. Move over to EQ, press reg EQ, and it'll pop up into L1, and then you can graph it. Okay. Again, this is a lot of using the computer, or using your calculators to find this. Okay, so your IRAT for this case, so your Individual Readiness Assurance Test, what you're going to do is you're going to classify these first two. So I would recommend putting into standard form, classify by both the degree and the number of terms. So again, the degree is your constant, quadratic, cubic, quartic, etc. Terms is your polynomials, monomial, trinomial, binomial.